Hi everyone, I'll be presenting problem 5 on this year's TST. So the problem is, David summons 10 birds to perch on the unit circle. Each bird chooses a location on the circle uniformly at random, independently of all other birds. What is the expected number of acute triangles with 3 distinct birds as vertices? Okay, so how do we approach this? So first notice that any triple of birds from the set of 10 birds is equally likely to form an acute triangle. So in particular, this means we can just take 10 choose 3 times the probability that any 3 birds form a acute triangle. So now it just remains to find this probability. So to do this, we can use geometric probability, which is basically when you want to find the probability of 2 continuous variables, you can graph them as variables on an axis and see what percentage or what fraction of the total area lies in the region that you want to describe. So without loss of generality, we can set one of the birds at, I don't know, this bottom point on the circle. And now we want these 2 other points to form an acute triangle. So what that means is they have to be on different sides of this line, because otherwise if they're on the same side, then that's clearly obtuse, right? And they, like, the diameter that they form, like for instance, we can't have this because then there's a diameter here, and then all 3 points lie on the same side of that diameter. So we can represent this as the difference between this arc this way of this point and the arc this way of this point. This difference must be at most 180 degrees. So if we put them on the axes with 360 degrees, all sides, then the probability they are on different sides is contained within these 2 squares. And then the probability that their difference is at most 180. Well, then we get either x minus y is at most 180 and y minus x is at most 180. So you can rewrite these equations to x is at most 180 plus y. We see that this equation has slope 1 and it passes through 180 comma 0. So that would be this line here. And similarly, the other inequality has a border formed by this line here. So the region of points that is satisfied will be this region here, and this region here. So in particular, that means these 2 triangles represent all the possible values of arguments for these 2 points that form an acute triangle. So basic geometry, we find that you can put these 2 triangles together to make a square. The square is 1/4 of the total square, so the probability is equal to 1/4. So we get 10 choose 3 times 1/4. And 10 choose 3 is 10 times 9 times 8 over 3 times 2, which is equal to, if I'm correct, 120. So then our final answer is 30, and we're done.